Okay guys, welcome once more to Prepclass online class, and my name is Mr. Damilola Shotayo. In this edition we shall look at physics past question 2019 number 31 to number 35. And if you like this video, please click on the like button or subscribe so that you can get more content from us from time to time. Don't forget to also tell your friends about us and tell to help them. And now let's look at number 31. It's now an electron of mass 9.1 times 10 to the power minus 31 kilogram move with a speed of 2.0 times 10 to the power 6 meters per second round the nucleus of an atom in a circular path of radius 6.1 times 10 to the power minus 11 meter. Now calculate the centripetal force acting on the electron. Very straightforward. Now when you hear centripetal, a formula should come to your mind, right? Is there a formula coming to your mind? When you see centripetal force as a formula, and once you know that formula, then this question is done for. Okay, so let's check out. Now don't forget the formula that you see now. Centripetal force is just mv squared over r. You know, mv is momentum, kind of. You know, momentum is mv. So if you see mv squared, it's like saying I just said that personally. I'll just say is momentum squared over radius. That's all. That's centripetal force. Now, actually, centripetal force can modify into 2 because V has its own formula too, which is RW. So, if you solve that, you also get the second formula, MRW squared. So it can be, but the most popular is MV squared over R. But also, it can also be MRW squared, which is M is mass, R is radius, W is angular velocity, and while V is velocity. Now, centripetal force, you must also know, because we have different questions from time to time. Centripetal force, you know, when your fan is rolling and they take up the light, what is the force that keeps the fan rolling? It's called centripetal force. It's this force that keeps something in circular path. So if my fan is rolling and never take light, you get that kind of thing. The fan keep rolling, right? It keep rolling. What's the force keeping it moving, keeping it rolling in circular path? It's called centripetal force. So centripetal force is simply the force that make an object to follow a circular path. Okay, now let's talk about this formula now. It is either mv squared over r or mrw squared. If you know that, then you've mastered circular motion. You know, in the previous video we have a formula in circular motion that is telling us about v is equal to wr. Now, the second most important formula in circular motion is centripetal force formula, and it is this one. If you master those two formulas, then you are really good in circular motion. And we have the parameters mass, velocity, and r given to us. Then let's check it out. So my F is equal to, that's my centripetal force, is equal to mv squared over r. My m is 9.1 times 10 to the power minus 31. My v is 2 times 10 to the power 6 squared. 2 outside. Okay, over 6.1 times 10 to the power minus 11. That's my r. So giving me 9.1 times 10 to the power 31 times 4. Where did the 4 came from? The 2 outside on the 2 inside. 2 raised to the power 2 gave me 4. Then 10 to the power 6 times the 2 outside gave me 10 to the power 12 divided by what is below. Okay, good. So if I solve that, remember I said this. Whenever you have questions that have 10 to the power something, don't do the 10 with the numbers. So I'm going to be separating 9.1 times 4 divided by 6.1, separate the numbers. Then the powers of 10 to the power minus 31 times 10 to the power 12. But the one below, 10 to the power minus 11, has to come up. And whenever minus goes up, it becomes plus. Don't forget that style. Now, if it is a plus below, if it goes up, it will become minus. So I have minus 31 plus 12, they are up, they won't change. But the minus 11 below, 10 to the power minus 11 below, will come up and become 10 to the power plus 11. Giving me, if you divide that 9.1 times 4 divided by 6.1, you'll be getting 5.97 times 10 to the power minus 31 plus 12 plus 11 will give minus 8 Newton. And that is the solution. So approximately 6 times 10 to the power minus 8 Newton for your centripetal force. Okay, no, 5.97 is approximately 6 times 10 to the power minus 8 Newton. That is the solution to that question, and that gives us my answer B as my answer, the option B as the answer to that question number 31. Straightforward, right? Now that's centripetal force. Okay, now let's check out number 2 now. Number 32 says a device consumes 100 watts of power which connected to 120 volt source. Find its resistance. Now you see power and you are seeing voltage and you are seeing to find resistance. You know, that should remind you of the power formula. So this formula can only be tackled by knowing the power formula for electric power. What's the formula for electric power? Do you have any idea? Okay, let's check it out. Now you can also learn that now. Now power, you can see 3 formulas for electric power. Any of them can work. The one I might like most is I times V, because that one is straightforward and simple. But you must also know all. You know, you can change them using Ohm's law, but generally you should know the 3 of them. I have to memorize the 3 of them, but I just have to memorize IV. Then from Ohm's law, I know that V is equals to IR, so I can modify them into each other. But what I do is that I just memorize one, P equals IV. Then I can get the others if I know my Ohm's law, which I know. Okay, so you may want to use my style. That's why I said that. Okay, so let's go. Generally, you can also just memorize all. R times I square, or IV, or V square over R. They are all power formula, and depending on the question, you may want to use any of them. You might use any of them. Now, this question, we were giving power. We were not giving resistance. We were giving current. Were we giving current? Yes, we were. Were we? No, we were not giving current. Okay, we were not giving current. So why did I put current there? That must be a mistake. Then we were giving voltage as okay, actually the reason why I put current there was because I look at the formula. I was trying to define all the terms in the formula of power. Okay, so my voltage is equals to, or my potential difference is equals to 120 volts. Okay, now which formula has the things given to us? We're to find resistance, we're giving power, we're giving voltage. So the formula that has power and voltage and resistance is P equals V square over R. You see, if you know only P is equals to IV and you were not giving I, what will you do? If it were me, I would just use the Ohm's law and modify it. But it is good to know how. So that P is equals to V square over R, right? Good. So to find the P, now we are told to find the R, that's the resistance. So making the resistance the subject, I will cross multiply. When I cross multiply, I will cross multiply, then I will have my PR equals V squared. Then if I divide both sides by P, I'll get my R equals V squared over P. That is the formula that will help you to find your R in this question. R equals V squared over P. What's my V? 120 volts. That's 120 squared over P, 100 watts. So if you have 120 squared, that's 1,000. That's actually 14,400 divided by 100. If you get that done, you will have 144 ohms as your resistance, and that is the simple answer to that simple question, and that gives me D as a correct option. Let's check out number 33 now. Which property of wave travel from one medium into another? Now, wave have different properties. You know, we have wavelength, velocity, frequency, amplitude. You know, amplitude is the distance moved by wave. It is either upward or downward. So it is the amount of displacement of wave is called amplitude. Wavelength, you know, length of the wave. You know, the distance between two successive crests or two successive trough. Yes, that's just wavelength. Then velocity is just generally we know that velocity is displacement over time. So then frequency is the amount of oscillation per second. So now I haven't defined all of them. Now which one does not change? Which property of wave travel from one medium to the other without changing? Okay, actually, if you will know that from knowing the refractive, this thing was mentioned when we studied refraction topic. Okay, the wave front does not pile up nor are created or destroyed at the boundary. Therefore, as light travels from one medium to the other, its frequency does not change. So frequency does not, when wave move from a medium to another medium, the refraction says that it bends, right? Good. Everything changes when wave bends. The speed, that's the wavelength, and the wave velocity or speed change. But there's one thing that does not change. The frequency of wave does not alter as it moves from one medium to the other. The frequency remains the same. So the property of wave that will not change as wave move is the frequency. Don't forget that. Very important. The frequency of wave does not change from medium to the other. Now let's check out number 34. The anomalous expansion of water occur in the range wall. Now, have you ever heard about this topic, anomalous under expansivity of water? Okay, generally expansivity. That's the topic. Okay, so now under the expansivity, we have this subtopic that spoke of the anomalous or the abnormal behavior of water. That says that everything expands when they are heated except water. water first of all expand, before it expands at 0 degrees Celsius, everything, if it is metal, when you eat a metal, it will expand, and that's why glass cups shatter when you eat them. Because it expands, and then if it expands too much, the abnormal expansion between the inside and the outside will cause it to break in pieces. So everything expands when it except water. Between 0 degrees Celsius, when you eat water, water does not expand first. Water first of all contracts. Don't forget that. And it is between this thing happen. If you have studied this topic, you will have known that it happened between 0 degrees Celsius to 4. Water does not behave normally like every other thing. Water behave abnormal. It's like it is like a madman. You know, that's not abnormal. Water does not behave sensibly. It behaves abnormally or anomalous expansion. So between 0 and 4, instead of expanding like every other thing on the earth, water contracts first. It reduces. Then from 4 degrees Celsius, it now begins to expand. So the answer to that question is from 0 to 4, water contracts. You can see that picture. Water contracts or reduce. That means it's reduced. Then from 4, it expands. So unlike most matter, water contracts between 0 to 4 degrees Celsius when heated before expanding from 4 degrees. This is called abnormal, and this is this is abnormal, and this is the anomalous expansion of water. So that's what it's all about. So the answer is option B, 0 to 4 degrees Celsius, water contract. Now number 35 says a ray of light traveling from the rectangular glass block of refractive index 1.5 into air strike the block at an angle of incidence of 30 degrees. Okay, calculate its angle of refraction. Now you see the word refraction should remind you of the topic refraction. Okay, now the angle of refraction, do you have any idea? Can you remember the formula for the angle of refraction? Now this formula is key. If you know this formula, then you'll be able to solve many questions on refraction. Okay, now what is the formula? What is the formula for the angle of refraction? Okay, let's check it out. Now the formula is very simple. That's the refractive angle equals sine of incidence over the sine of refraction. Full stop. That is called the refractive index. So the refractive index is equal to sine of incidence. Now this is according to Snell's rule. Now Snell's rule says that the angle of incidence and the refractive angle are directly proportional, and that gave us the formula for the refractive index. Okay, now if we've taken this topic on a later time, we will explain this more. But generally, notice that the formula for the angle of refraction is this. Okay, it says the refractive angle is equal to sine of incidence over the sine of refraction. Okay, and let's go. We were given that the refractive index is 1.5. The sine of incidence is 30. Now, what is this angle of refraction? Okay, so let's check it out. Now, substituting the refractive index 1.5 equals sine 30, since 30 is my incident angle, over the sine of refraction. Okay, if I cross multiply, I'll be having my sine of refraction equals sine of incident, sine 30 over the refractive angle. So sine 30 is 0.5 divided by 1.5, giving me 0.33. So that's sine r equals 0.33. But that's not the end. We have to find r, not sine r. So the sine will move to the right hand side and become sine inverse of 0.33. Or on your calculator, just press shift, then press sine. Shift sine, that's sine inverse of 0. Then you now press 0.33. So shift sine 0.33, that will give me 19.27. So the r, or the angle of refraction, yes, is 19.3, approximately 19.3, and that makes option B the correct answer. But you know, I have 19.3, but they were giving 19.5, and that's the closest. Actually, it's supposed to be 19.3, but we're giving 19.5. Maybe that may be a typo or whatever it is, but this is the closest to the answer, and I went for that. So 19.3 is the correct answer to that question, making option D possibly the correct answer to that question. Okay, the most important thing for you to know now is the way it is being solved. Okay, so that brings us to the end of this video session. Don't forget to like this video and to tell others about us, and to subscribe so that you can get more from us from time to time. Until we see you next time, take care of yourself. Bye for now.